In this video, we'll be taking a look at the progressive image sampler. Progressive image sampler is very similar to bucket image sampler, but instead of rendering the image in buckets, it renders the entire image progressively in passes. The main advantage of using progressive image sampler is going to be having a fast feedback. So instead of having to wait for all the buckets to render, you can see your entire image immediately after pressing the render button. Of course, if you have irradiance map or light cache as your secondary or primary GI engines, V-Ray first needs to calculate those before starting to progressively refine the entire image over time. We'll be using the same scene from our previous lesson. In the V-Ray tab, let's make sure our image sampler is set to progressive. Now let's come down to our progressive image sampler rollout. As you can see, we have our min subdivs, max subdivs, and noise thresholds, and they function exactly like in the bucket image sampler rollout. We have two new parameters, render time and ray bundle size. Render time is the maximum render time in minutes. Right now the render time is set to 0.5, so the render will stop after half a minute. And this time does not include any GI calculation. So if you are using irradiance map and light cache as your GI engines and the calculation of those takes, let's say 4 minutes, this half minutes begins after the GI has finished calculating. Obviously, something like brute force does not need any pre-pass calculation. If you are only using brute force as your GI engines, your final progressive render starts immediately and stops after half a minute. Also, you can set the render time to 0, and this way the render won't be limited to time and it will continue until either you stop it manually or the defined max subdivs and noise thresholds has reached. In the GI tab, I have irradiance map as my primary engine and light cache as my secondary engine. To increase the speed, let me set irradiance map preset to low and subdivs to 50. And interpolation samples to 20 and set the light cache subdivs to 500. Now let's get back to the V-Ray tab and we can start the render with the default image sampler settings. As you can see, first the irradiance map and the light cache will be calculated, and after that the image will be rendered for half a minute. As you can see, immediately after the GI calculation, we can see our entire image being progressively refined over half a minute. At first, the image is very noisy, but we can see the entire image and get a very good idea of the overall look and lighting of the scene. And then as it goes through, it kind of refines the image progressively until that half a minute reaches, and then it will stop the render. Now let's get back to the GI tab and set the irradiance map preset to medium, subdivs to 75, and interpolation samples to 25. I've already saved out the irradiance map in the render output folder for this lesson, so let's change the irradiance map mode to from file, and in the render output folder of this lesson you can find the irradiance map, or you can save and use your own map. Also, for the light cache, let's set the subdivs to 1000, change the mode to from file, and in the same folder you can find the light cache map based on these settings. Perfect. Now, if we render the scene, we don't need to calculate GI first, and it will render the final image immediately. In the progressive image sampler rollout, let's set the render time to 0, and now the render will stop only when we stop it manually or if the max subdivs and the noise threshold is reached. So let's start the render. Now immediately we start progressively rendering the final image, and it gets cleaner and cleaner by the time. You can see after a few minutes it gets very clean, and we didn't have to wait for all the buckets to come in and render our scene. Now I can go ahead and stop the render if I wanted to, and whenever I want, and be happy with it. One of the issues with the progressive image sampler is the RAM usage, especially if you have render elements added to your render, because the entire image data is always kept in memory while rendering. It's going to need more RAM compared to bucket image sampler, right? Also, when using distributed rendering, because we constantly refine the image, the communication between the client and the servers is a lot, and that might lead to less than optimized CPU utilization on the render slaves. This problem can be controlled using ray bundle size parameter and mean shading rate value. Basically, higher values for ray bundle size makes the chunk of work done by each machine bigger, and therefore optimizing CPU utilization a bit better. Also, if I quote Chaos Group website, in contrast with the bucket image sampler, the progressive image sampler doesn't have a mechanism to recover if a DR server goes offline during rendering before sending back the results from its calculations. The render progress might hang indefinitely waiting for the missing data to arrive. This will be corrected in a future release. End of the quote. The question here is which image sampler is better for which situation. For final renders, I barely use progressive sampler. Progressive sampler is amazing for fast feedbacks. When you start working on a project and you want to see how your light and shaders look in the scene, and you don't want to wait all the time, using progressive image sampler is very useful in those situations. Obviously, you have V-Ray RT, which we have used a few times in the course, and we'll be learning more about it later on. But sometimes the scene is a bit more complex. You might not have the resources to see the changes in real time using V-Ray RT. In those cases, progressive rendering can be very helpful. Also, sometimes when you want to render an animation and only spend a defined amount of time per frame to render, you can use progressive image sampler and set your desired time as your render time. Bucket rendering is preferred when using distributed rendering, as it can reduce the network traffic and prevent possible loss of information that we discussed when using progressive image sampler. So in this lesson, we learned about progressive image sampler and compared it to bucket image sampler. In the next lesson, we discuss global DMC options.